All right, so our I can statement is I can reflect and translate figures in the coordinate plane. Remember, when we're in the coordinate plane, that is analytic geometry. Okay, so this is a little bit different than the last couple of days, because the last couple of days we did synthetic. All right, so a reflection is a transformation across a line. Remember, we call that line the line of reflection, sometimes the line of symmetry, axis of symmetry. Those are all referring to the line that we reflect in or over. Sometimes it says reflect in the line or reflect over the line. Either way, it means we're flipping it, right? Okay. Now, when we reflect it, the two things I've made a big deal about are what? What has to happen in a reflection? From the pre-image to the image point, the pre-image and the image point, how do they relate to the line of reflection? Same distance. What's another word for same distance? Congruent or? Ooh, yes, equidistant. So congruent or equidistant, right? Okay, now if I connect the image point and its pre-image and I connect them, what do I know about this connection segment compared to the line? Good, they are perpendicular. So they have to be perpendicular and these have to be congruent. Otherwise, you don't have a reflection. Okay? Those two things have to occur to have a reflection. That's why we did it. That's why we did the construction, so that you could see. Those have to be equidistant and you have to have perpendicular lines there. All right, so that's what it says here. The line of reflection is the perpendicular bisector, right? Because we did that construction first, and then we said, oh, wait, we're doing a reflection. It's the same construction, okay? So perpendicular bisector of each segment, joining each point at its image. The pre-image and the image must be, again, what you said, equidistant. Tell your neighbor, what does equidistant mean again? Same distances, equal distances, good. From the line of reflection. That's why we have congruent segments here. All right, so there's actually a pattern that happens when you do reflections on the coordinate plane, okay? So if you'll notice, if I have this point, actually let's name the quadrants, okay? First quadrant is here. Which direction do we go? What's the positive direction? Left, counterclockwise. So we count left. 1, this is quadrant 2, this is quadrant 3, this is quadrant 4, right? Okay. And so what happens is, and you can tell by the quadrants, this quadrant is a positive, positive, right? This quadrant is what? Nope. Negative, positive. There you go. It's X first, then Y. Okay, what's this quadrant? Negative, negative. What's this quadrant? Positive, negative. Okay, because always X first, horizontal first, and then vertical. Okay, so if I have my pre-image in quadrant 1, when I reflect it over the x-axis, okay, what happens? Which value changes? The y, right? The y becomes the opposite. Right? It becomes the opposite, negative. And if I were here and I reflected up, the y would become the opposite, right? Okay. So here, when we reflect across the x-axis, the y becomes the opposite sign. So if it's positive, it becomes negative. If it's negative, it becomes positive. Good morning. I want one of these. Just save this for tomorrow. Did she put in a pass for you on the? Okay, I'll get it. Okay, so when we reflect over the y-axis, what do you notice happens? Wait, which one changes? The x. So this time the x changes. So it's kind of the opposite of what you think. When you reflect over the x, the y changes. When you reflect over the y, the x changes. Okay, so the x is going to change signs here. Let's write that down. I'm going to get this capsule first. Okay. Now, when we reflect over a line that is not horizontal or vertical, but is actually diagonal, okay? So the first one is this positive line. It's called y equals x. Remember this from algebra? Okay, y equals x, its slope is up 1 to the right 1, up 1 to the right 1, or down 1 to the left. Okay, so this right here is your parent function for your linear equations, right? So when we reflect over the y equals x, okay, notice that signs don't change this time. What happens this time? Yeah, the y becomes the x becomes the y. Okay, so when we reflect diagonally, the y becomes the x becomes the y. Okay, and remember this notation here. This is what you start with, your pre-image. When you transform it, this would be your image. Okay, now if we were to reflect over the negative of that line, so this one time is decreasing, okay, again, our y and our x flip. What also happens this time? The signs change too. So if they're positive, they become negative. If they're negative, they become positive. So we not only change, our x becomes our y and our y becomes our x, but their signs also change. Okay? All right, so let's flip and let's practice that. So you probably want a highlighter or another color. I like to highlight or color another color my reflection line, just so I know which way I'm going. Okay. So the first one says, reflect the triangle with vertices, and it gives us the vertices, and they've already been, our pre-image has already been graphed, but we're going to go across the y-axis. So I'm going to highlight the y-axis. Which one is that? Yep, straight up and down, right? This one. So I'm going to highlight this one. And I'm going to visualize it, okay? So if I am reflecting this, z should end up where? On the other side, right? Same distance, other side. Where should x end up? Yeah. Yeah, in that quadrant 3, right? Where should y end up? Yeah, in quadrant 4, same distance, other side. Okay? So if you don't remember what the pattern is, you can figure it out, because you know it has to be the same distance from that line, right? And we have to have perpendicular segments. Okay, so what happens is we're reflecting over this. If I'm moving from one side to the other horizontally, which value of the coordinate is going to get affected? If I'm moving horizontally, the x is affected, right? What happens to the x? Yeah, it goes the opposite sign, right? It doesn't necessarily, I like to say it goes the opposite sign, because sometimes you start negative and it would become positive, okay? So it goes to the opposite sign. So the rule is, if I'm going to transform it over the y-axis, this is called coordinate notation, okay? What happens is my x becomes the opposite sign and my y stays the same. Okay, so even before I graph it, I could write down what my new points will be, and this is how I write them. X is my pre-image, and I'm going to transform it to the image, so it'll be x prime. So what should happen is 2 should become the opposite, and y should stay the same. Okay, if y is -4, -3, y prime, -4 should become the opposite, and the y value should stay the same. Okay, z is at 3, 2. Z prime, again, the x should become the opposite, and the y stays the same. Okay, so let's graph it and make sure that that's right. So x prime is at -2, -1. So that's x prime. Y prime is at 4, -3. And z prime is at -3, 2. Okay, so I'm going to connect those. Okay, and I can check. X prime is 2 away from the line of reflection, and x is also 2 away on the opposite side. Okay, I can also check. There is from x to z, I would have to go up 3 and over 1. Is that the same thing? Up 3 and over 1? Yeah. If I folded it, would it fold onto the pre-image? Yes. Okay. Let's talk about function notation real quickly. So this is coordinate notation, right? Coordinate notation. Function notation is what we did last time. So what is the notation for reflection? Little r, right? Lowercase r. Now, we need the line here. What's the actual line for the y-axis? What do I call it?
X equals 0.
Good. This is going to be x equals 0. So that's what I put. I'm reflecting over x equals 0. And then what am I reflecting? Triangle. Yeah, zyx, xyz. Does it matter the order? Nope. Doesn't matter the order. Okay, questions? Any questions? Okay. All right, let's go example number 2. Because this time it is not an axis, is it? Where is x equals 1?
The vertical line right next to on the right of the
Yeah.
line.
So we go to x, where equals 1, right? So where x equals 1 is right here. And since x equals 1, it goes straight down, yeah, up and down. Because I always think of it this way. If there's no y in this equation, my line cannot cross the y-axis, right? If there was no x in this equation, my line could not cross the x-axis. So the only way to draw this line so it doesn't cross the y-axis is straight up and down. So it would be like this. Okay. So here we go. This one's a little bit different because we are not on an axis, right? So we might have to actually count on this one and see what's happening here. All right, so let's start with S. S is at 3, 4. So S prime, we know it has to end up over here, right? How far away is it from the line of reflection? 1, 2, huh? Yeah, 2, right? So then we're going to go 2 more to the left, and our S prime should be here. Does that make sense? Okay, so S prime is at -1, 4. Okay, so T again, 2 to the right, so we got to go 2 to the left, 1, 2. T prime. Don't forget to put your primes. That's at -1, 1. U. So U, how far away is it from the line of reflection? U is 1, 2, 3. So which direction am I going? To the right, 3 more, right? 1, 2, 3. So U prime would be here, which is 4, 1. Okay, and then V is at negative 2, 4. So V prime, so 3 from the left, so I go 3 to the right, and so V prime is here, and that's 4, 4. Okay, and then I'm going to connect those. Trying to make it a little bit darker so you can see it. Okay, remember that this is x equals 1. Okay, so if you'll notice when we write this notation, what's actually happened. Okay, let's just look at the y's first. What do you notice about y to the image y? They stay the same. Okay, so y is staying the same. Okay. But x is doing something a little bit different, right? Now, first off, what do you notice? From 3 to negative 1, 3 to negative 1, negative 2 to 4, negative 2 to 4. What happened? Okay, the sign is changing because that we always, and that negative in front of the variable tells us that it reflected. So we know we have a change in sign. Okay, so if I change my 3 to a negative 3, what do I do to that negative 3 to get to a negative 1? I would add 2, right? Okay, same thing. This is the same. Let's check and see if this works. Okay, so if I change my negative 2 to a positive 2, what do I add to it to get to the 4? A 2. So my rule is I changed the sign and then I did what? Add 2. Do you see what happened? See how that I got that rule? Okay.
So how did you get 2? Because U is just negative 2, 1.
Yep, I changed the sign. So my negative 2 became positive 2.
Oh, okay.
And then I asked myself, okay, after I change the sign, how do I get to 4? That's where I want to end up, right?
Yeah.
So I changed the sign and then added 2.
Okay,
And any point on this image, if I found its pre-image, it would be that same pattern in this instance. Okay. Function notation, we would write reflect over the line x equals 1. And then this is a quadrilateral. We're just going to put in order STUV. It doesn't matter where you start as long as you go consistently around. So you could go TUVS or UVST. All right, let's do another one. Okay, what's different about this one?
We have to go through ourselves.
Okay, well, what's our line of reflection? Okay, y equals negative x. Okay, where is that? Where is y equals negative x? Okay, well, if we start at 0, how do we get from 0 to it? What's our slope here? Because that will help us. You said negative 1, right? So our slope here is negative 1. How do we use that slope to get to the next point? What does it tell us? Okay, go down 1 and to the right 1, right? Down 1 to the right 1, down 1 to the right 1. What other direction could I go? Good. Up 1 and to the left, up to the left, up to the left. You guys remember how slope works? It's your map to get to the next point. Okay. So my line of reflection is actually a diagonal line, because when I see a y and an x in my equation, I know I'm going to have a diagonal line. Okay. So I'm going to go ahead and I have this upside down. going to highlight that. Okay, I'm going to plot my two pre-image points. So R is at -2, 2, so R is here. And S is at 5, 0, so 5, 0 would be here. And it says it's a segment, so I'm going to connect them. All right, so if I reflect this, this is one of the patterns that I told you about. Does anybody remember what happens? Just think about it.
They're gonna flip.
Okay, they're going to flip. So Y is going to become X, X is going to become Y. What else? Anything else happen? The signs are going to change. They're going to flip and the signs are going to change. Okay, so R is at -2, 2. What's the new point for R prime if they flip and the signs change? So you flip them, right? So it would be 2, -2, and then you change the signs. What does that become? Why is it the same?
Because it's on the line.
Yeah, this one's on the line of reflection, so it should be the same. Okay, so S is 5, 0. So S prime, if I flip it, 0, then 5. And then I change the signs. Does 0 actually have a sign? Nope, it just stays 0. What does the 5 become? -5. Do what? How is Y? Ask it again. How are they flipped? Well, this is why they're flipped. S has to go across this line of reflection the same distance, right? Okay, and so when that occurs, watch what happens. And I can look at it like this. I can go 1, 2, and a half, right? Half, 1, 2. So S should be down here if I counted it out. Okay, so what is the point here? What's this point called? Well, what's the X value of this point? 0, right? What's the Y value? -5. So anytime you flip over this line of reflection, the pattern that happens is that they switch places, the X and the Y values switch places, and they become the opposite signs. Yep, so this is your new S prime, and this is R prime because it stays on the line of reflection, and then we're just going to draw the segment. And we've reflected that segment. Questions? Okay, how would I write this in function notation? Little r, subscript is, and then segment RS, right? Segment RS.
Does the order matter for the segment?
No, since they didn't give it to me first, I'm just going to put it in the order I see it. That's fine. Okay, tomorrow we will translate in the coordinate plane, okay? What I would suggest to you is you need to know these reflections. You need to know these patterns, okay? You need to know these patterns. Any questions? Okay.